Bismillahirrahmanirrahim. In this topic, we are going to speak about the inverse functions. Let's define first the meaning of the word function and then speak about the inverse. Usually, the function is defined as a set of ordered pairs where there is no repetition in the x-coordinates. So it is a set. We can say the function is a set of ordered pairs. Or a function is a set of ordered pairs. But with one condition, that there is no repetition in the x-coordinate of the ordered pairs, or we don't have two ordered pairs with the same x-coordinate but different y-coordinates. You can say that simply with no repetition of the x-coordinates. Means, for example, say number one, set of ordered pairs. For example, if you have 1 and 2, 3 and 5, 5 and 6, 7 and let's say 9 and 0 and 2. If we look for this set of the ordered pairs, to check whether it is a function or not, we look for the first coordinate of each ordered pair. So for example, the first one is 1, second one is 3, 5, 7, and 0. So we can see that there is no repetition in the x-coordinate. In this case, we say this is a function. So this is a function with domain equal to 1, 3, 5, 7, and 0. The second coordinate or the y-coordinate is equal to the range of the function. So the domain for this one is 1, 3, 5, 7, 0, and the range is 2, 5, 6, 9, and 2. So the main part for the definition of the function is the domain. If we represent this using the arrow figure or drawing, the first one equals the domain, which is we have 1, we have 3, we have 5, 7, and 0. Second coordinates are 2, 5, 6, 9, and again 2, which is repeated up. So if you connect between the first set and the second set, we can say that 1 is equal to 2. We call that 2 is the image of the element 1. So the number 2 is the image of the first element or of the 1. Second, 3 will go for 5. 5 will go for 6. This is 5. And we have 7 go for 9, and 0 will go for 2 again. So if we look at the first set, this for the domain, this is the domain. And this one is equal to the range of the function. So to decide whether this relation is a function or not, we are looking at the domain and see if each element in the domain has only one image in the range, then it is a function. So if every element in the domain has one image in the range. Or we can say one arrow is coming out from each element, goes to the range. This is a function. Example number 2. If I have 2 and 1, 4 and 0, 3 and 5 and 2 and let's say -1. So if we represent this using the drawing or the arrow drawings, the domain is the first element, so it is 2, 4, 3, and 2 again. We have 2. The range is the second coordinate, which is 1, 0, 5, and -1. Now the first order where 2 goes to 1, 4 goes to 0, 3 goes to 5, and 2 goes to -1. Now if you look at the first set, this one, we will see that the number 2, or the element 2, has 2 images. 2 goes to 1 and 2 goes to -2. In this case, we say this is not a function. So this is not a function because the element 2 has 2 images. 2. So this is not a function. So this is the meaning of the word function. The function is just a relation, or it is a set of ordered pair where there's no repetition in the x-coordinate or the element in the domain. Each element of the domain has only one image in the range. Each element in the domain has only one image in the range. Now for the inverse, let's speak about the reverse first, not the inverse. For the first part, or the first example, this one. If we look at the reverse, I'm going to reverse, not the inverse. Let's take the reverse. For the reverse, I have 1, 3, 5, 7, 0. Second set is 2, 5, 6, 9. Now the reverse for this one, we have 2 will go for 1, 5 goes to 3, 6 goes to 5, 9 goes to 7, and 2 goes for 0. Now the reverse of this function is not a function because the number 2 has 2 images if we reverse the direction of the arrows. So this is not a function. So I have a function, but the reverse is not a function, which means we have some functions that doesn't have inverse function. The inverse function is just the reverse of the ordered pairs. Y will be x and x equal to y, or just reverse. Instead of xy, we will write it as yx. So to define the inverse function, we have to put one condition. We say that a function f has an inverse function f and only f. We say f double f means f and only f. F is 1 to 1. function. Now, what do we mean? What do we mean by one-to-one function? We said that a function is a relation in which there is no repetition in the x-coordinate. So this is to define the function. Now, one-to-one, we are looking at the range in this case. For example, I have 1, 2, 4, and 5. And let's say 6, 7, 8, 9. Go for 7, 2 go for 6, 4 for 8, and 5 for 9, for example. This is a function. Yes, this is a function because each element in the domain or in the first state has only one image in the range. Now for one-to-one, we are looking at the range, looking at the range of the function, this one. Each element in the range, does it have only one pre-image, or it is connected only to one element in the domain or not? If each element in the range is connected to exactly one element in the domain, we call it one-to-one. So one-to-one means every element in the domain element in the range is connected with or to only one element in the domain. So for the one-to-one, looking at the range, we are looking at the range of the function. If each element in the range is connected to or connected with only one element in the domain, then we call it is one-to-one. So for a function to have an inverse, it must be one-to-one function. Because if we reverse the order for this one, now this one had the set, we can write it as order pair as 1, 7, 2, 6, 4, 8, and we have 5 and 9. Now the inverse for this one is equal to, just reverse the order. The first one is 1, 7, it will be 7, 1. Second one will be 6 and 2. Third one will be 8 and 4. Fourth one is 9 and 5. And you can see it is very clear that this is a function. So for to find the inverse function or for a function to have an inverse, it must be one-to-one. Each element in the range has only one pre-image. It's connected only to one element in the domain. This is the meaning of the one-to-one. Sometimes we are using something called the horizontal line test to check whether it is a one-to-one or not. We use something called the horizontal line. If I have a graph, for example, this is a function y equal to x squared. If we graph a horizontal line, and if the horizontal line intersects the graph of the function in more than one point, then it is not one-to-one. For example, this is not one-to-one. Because the horizontal line intersects the graph of the function in more than one point. For example, the sine function. This will come later on in this course. The sine function It's just like a wave. And if we graph a horizontal line, you can see it intersect the graph in more than one point. This is y equal to sine x. So we can see the horizontal line is intersecting the figure in more than one point. So this is not one-to-one function. If we restrict the domain and make it shorter, it might be one-to-one, but as it is from minus pi over 2 to pi over 2, it is not one-to-one function. So this is the idea of one-to-one function. If the function is not one-to-one function, then we cannot find the inverse for this function. Any function which is not one-to-one doesn't have an inverse function because the reverse will not be a function, as we stated before in the first example. This one, or the first example, this one. It is a function, but the reverse is not a function because it is not one-to-one. So this is the idea of the one-to-one function, or the meaning of one-to-one function. In the coming part, we are going to speak about or to check whether the two functions are inverses or not. We are using the composition of inverse functions and property. This will be in the coming part.